Okay, so we've ascertained that 5,000 newtons is our force. We've also ascertained that friction is the source of F sub c. Okay, now, I said F sub c, anywhere, anytime in the universe that something moves in a circle. William, what did I say that equals? Here's a hint. What does F sub c equal?
Centripetal force.
True. What equation is that?
Oh, velocity squared times your mass over r.
There you go. mv squared over r. Anything, anywhere, anytime, moving in a circle, the sum of the forces is mv squared over r. Incontrovertible, right? There is no F sub c. There is something else causing F sub c, right? So there's normal force, there's friction, there's tension, there's gravity, there's electrostatics, there's magnetism, whatever. Something is causing mv squared over r. Does that make sense to you? Okay. Everybody with me? How are we doing? Okay, and I'm assuming you just used this equation to get F sub c, did you not? Okay, so now, if you would, with your partner, you know that this is the sum of the forces on this. You also know that friction is what's causing this. Find mu. Go. All right, so hopefully what you did was you said F sub f is equal to mv squared over r. And F sub f is equal to mu F sub n. And then mu F sub n is equal to mu mg. So we cancel the m's, divide both sides by g, and we get mu is v squared over gr. All right, questions? Anyone? Anyone? Bueller? Okay, very good. Okay, so this person, 5-meter long rope, 75 kilograms, rope's at 45 degrees. Maximum tension is actually supposed to be 1,100, not.
Is there no eraser?
Yeah, the eraser is weird. I don't know why. Sometimes it doesn't work. But 1,100 is the maximum force. So if we do this, what forces are on that thing? Let's see. Randy. Or Ryan, sorry. Sorry. Ryan. What forces are on that guy at the bottom of the rope? What? Okay, force of gravity going straight down. So we got F sub g like that. Yes? Okay. Let's see. And what else? Fn. What's it touching? So you're saying that's the force of the rope, you mean? Which would be tension. Very good. Way to change that yourself. Good. That's tension. Any other issues there? Any other forces? What's that? What force is swinging him? Does he have a jetpack? Is there something, you know what I mean? Is there something, in order to add any of the force, you have to ask, what is pushing or pulling this guy? So yeah, that's, we're assuming we neglect friction, we can say we're done. Now, anywhere, anytime, in the universe, the sum of the forces of an object moving in a circle is what, Terrence? Anywhere, anytime in the universe, the sum of the forces on an object that is moving in a circle is what? Frida? Yeah, FC. And what does FC equal? mv squared over r. So we're going to say the sum of the forces on this is going to equal mv squared over r. Does that make sense to you all? Yes? No? Okay. So, Natalie, what are the two forces fighting on this guy at the bottom of the rope? Yeah, what are those two forces fighting, like pulling up and down on the ball right there? Yeah, what are they? T stands for tension, FG stands for. Now, who do you think's winning? What happens if FG wins? What happens to the guy? Yeah, he falls. What happens if tension wins? Right, now, over here, I wrote, right here, I wrote some of the forces, yes? So if I say some of the forces, I'm just adding up the forces, yes? Does this make sense? I'm just adding up the forces on the object. So then I'm going to say tension minus Fg equals mv squared over r. Of course, this lets me say tension equals mv squared over r plus mg. So I get m times v squared over r plus g. So that gives me 75 kilograms times v squared over r plus g. Wait a minute. What's v? Dun, dun, dun. We have to figure out v. Okay, and how did you get that, Alex?
I divide m and minus b and r and square root v.
I did another way though. I did do all the algebra before doing.
I shouldn't have asked. He always picks the hardest way in the world to do everything. No, he does everything in a very efficient way for himself, so that's fine. What I would do is I would say, if you remember, okay, I hope that works. Anyways, if we look at this guy here, right, what we could do is just say, okay, does it make sense to you that gravity in this sort of angular sense is moving him perpendicular to the string? And then perpendicular to the string, that part of gravity is g sine theta, right? Okay, so all we have to do is come up with a differential statement that describes force as a function of theta, right? And then just integrate that from 0 to pi over 4, and we're good. Does that make sense? Of course not. This isn't calculus-based physics. I'm just kidding. We're not really going to do that. We're going to do something a lot more. I really hope that's working. If I go back to here, I'm taking v squared. So this is going to become m times 2gh over r plus g. Right, so all I got to do is find the change in height, because h is going to be this. Right, well, do you see that this right here is L cos theta? So then h is equal, do you remember this? L minus L cos theta? Yeah, so then if I do that, I should get something like 1.5 meters. Because cosine of 45 is about 0.7071 times 5 gives you 3.5 approximately. Subtract that from 5, you get 1.5. So I have a height of 1.5 meters. So then, now I can plug that in, and I should get 2 times g times h, so that's 3 times 10 is 30, divided by 5 is 6, plus 10 is 16, 16 times 75, 16, that's 750, and then 420, so 4 is any, I don't know, like 1,200 or something? Mwah, mwah.
You got it.
1,200 newtons, this person is shark bait. Does this make sense? Questions? Questions? Now, this is the fun part, right? Do you see what I could do right now is say to you, okay then, from how high, how low does this person have to get their body so that they could actually make it? Right? And so what you would have to do is say, well, his mass, you can't change that. So the the gravity is always going to be 750. So 750 from 1100 means I have 400 newtons of tension caused by his swing. So if I set that equal to mv squared over r, I can now get exactly how fast he can be moving. And if I take that and set it equal to square root of 2gh, I can find out how high up he can swing down from. And based on that, you can figure out where does he have to go to swing so that he can survive. All right? Which would be a really cool quiz/test question. Because then I can walk you through all this and then back it out the other way and get a different question altogether, which is fun. All right? And with that said, straightforward. Okay? And hopefully that straightforward thing is, how do you find the speed of something at the bottom, like when it's gone from a high place to a low place? What system do we have that allows us to compare an object at two positions and come up with its characteristics? Yeah, conservation of energy, MEI equals MEF, yes? So if I say MEI equals MEF, then I'm going to say MGH equals 1/2 mv squared. That goes away, and I get v is equal to the square root of 2gh. Or I'm getting v squared equals 2gh, right? Okay, I lost my cap. If you remember, in the past, we've talked about, objects that, good gravy. This thing is like made of non-stick surface or something. Okay, anyways, we've talked about how you analyze how fast something's moving when it gets to